Angles inside, outside, and segment formulas. This is the second video in the series on my channel, and so if you want to understand the circle basics, you should watch video 1. I highly encourage it. And this is by Think Sapling. Today we will be going over circle diagrams and more formulas, angles inside the circle theorem, angles outside the circle theorem, the circumscribed angle theorem, segments of chords theorem, segments of secants theorem, segments of secants and tangents theorem, and external tangent and secant segments. So first we're going to be doing the circle diagram and more formulas. So this is our circle diagram, right? And if you see angle 1 here, half of MAB. So whenever you see a line above letters, that means the line. Whenever you see a little like parentheses sideways over a couple of letters, that just means the circle. If you see the circle, there's more likely 3 letters that go like there's a point in the middle, so you know the circle, not just the diameter. So for angle 1, half of the diameter here, or the line AB, half of that is what angle 1 is equal to. Let's say this is 180, half of that would be 90, right? So this angle will be equal to 90. Now angle 2, half of BCA, this time it's the circle, half of BCA is equal to angle 2. So as you see, you could also do that with this side. I'm just showing you 2 different ways you can find out what these angles are. Okay, now we're going to do angles inside the circle theorem. So angles inside the circle theorem, angle 1, half of DC and AB is equal to angle 1. Okay, and this angle right here, if they are like congruent and everything, then that angle too. So half of these two is equal to this angle. Now for angle 2, half of AD and BC is equal to angle 2. So basically the exact same thing, right? Now, angles outside the circle theorem. Okay, so as you see, angle 1 is equal to half of BC. So you see this BC here, minus AC. So whenever you see an angle, see this angle, right, and it looks like this, there's one like going like that, and there's one going through the middle, half of the outer minus the inner. It will always be outer minus inner because you cannot have a negative angle. Okay? That's how that one works. Now for this angle, we're going to label this angle angle 2, half of PQR minus PR. So basically the same thing, except this time both the lines are outside, and this one line was inside, one line was outside. Okay? Now, for angle 3, we've labeled this little angle in here, angle 3, half of XY minus WC. Remember, it's half times the difference for all of these, okay? And so basically, no matter what the lines are, if one is outside, one is inside, both are outside or both are inside, it is basically the same formula. Half of the outer minus the inner. Okay? Now, a circumscribed angle. So what is a circumscribed angle? It is an angle whose sides are tangent to a circle. So a tangent to a circle, you might have to see my other video to find out what tangent is, but you see these 2 lines are touching the circle at a point, right? So these 2 lines are tangent, and this angle is made of these 2 lines. And these 2 lines are tangent to the circle, which means this angle is circumscribed, okay? So now we're going to do a circumscribed angle theorem. The circumscribed angle theorem is that ADB, so you see this little angle right here, ADB is equal to 180 minus ACB. So if you have this, right, you don't need to do this. If you have this, then you do 180 minus this. Okay, that is the circumscribed angle theorem. okay? This was over here, this was the angles outside the circle theorem. This was a circumscribed angle, okay? And so if you had the point and if you had that measure, you could do this formula instead of this formula, okay? It matters. What do you have that you can use? If you have this and this, then you can, if you have AB and AB, then you could do that, right? You could do the angles outside the circle theorem, but if you have this triangle measure right here, then you could do 180 minus ACB, okay? Now we're going to do the segments of chords theorem. So segments of chords theorem is EA times EB is equal to EC times ED. So basically just lines. This one I find very fun to do whenever you do problems. It's really easy to go from one side to another times one side to another to find out. Sometimes it's like, okay, AE is 7, EB is X, CE is, I don't know, 6, and ED is 3. Like, what is it? It's like 18 over 7. You see what I'm saying? Okay? So now when you look at it, you're like, oh my god, I learned this much. But it's actually really simple. Okay? Now, segments of Secant's theorem. So, if you see here, this is what we had been going over before. Right here, that is this diagram right here. Okay? But this time we're trying to find out the lines are, not angles. Okay? So as you remember, this is a secant. These are secants. Okay? EA, this one outside here, times EB, so this whole thing. So this is where many people mess up. They forget to do whole, and they go back to this one. They think, oh, if this one, you only do part times part, right? And this equal another part times part. They think that also applies here, but it doesn't. The outside times the whole is equal to the other outside times the whole. You have to remember there is a difference, okay? There's a very big difference. This is very hard to remember. So let's say you're trying to find out AB is, and let's say this one's 2, right? So EA, let's say, is 2. Okay, let's put that as 2. And AB is X. Okay? And you have EC and you have CD. Let's say EC is 3 and CD is 4. Okay, let's solve that on right here. What is EA? EA times EB. What is EB? It is 2 plus X. Okay, that is what EB is. You have to add it. This is where many people are like, this doesn't make sense because I need all the numbers. Well, no, sometimes you don't. Okay, is equal to EC times ED. Now, when I say ED, sometimes people remember to do the 2 plus X because there's an X there. It's sort of different. But sometimes people forget. Sometimes people just put 4 here. That's not how that works. Okay, so then you put 7 here. Okay. So now what we're going to do is 4 plus 2x is equal to 21. 2x is equal to, you guys can do the math right now. Right? Just giving you all time to do the math. Okay, 17 over 2. So basically 8.5 is equal to X here. Okay? That is basically what we're trying to do there. Okay, I'm just trying to clean this up really. Okay, so I hope that made sense. Okay, so now we're going to go to segments of secants and tangents theorem. So, in this theorem, there's one that's outside, and it just touches the circle at a point, right? That's EA. And then this one is like outer, and then our EC and CD, right? So if we take this outer one and square it, it's equal to EC times ED. Remember, this one's full again. So basically, this segments of chords theorem, segments of secants theorem, and segments of secants and tangents theorem are very easy to mess up and mix around. So you have to like remember them, practice them a lot just to make sure you know the difference between them. Okay? So let me just make a quick problem for this one for you really quickly. Okay, I quickly made a problem for you right here. Okay, you can take a minute to solve it and pause the video if you have to. Okay, now let's solve it. EA squared, which is 4. Okay, so we're just going to solve it on this purple here. 4 squared is equal to EC times ED. Remember, it's ED, so x plus 2. Sorry, that was really bad, but okay. So what is 4 squared? That is 16 is equal to 2x plus 4. 2x is equal to 12. So basically x is equal to 6. So CD is equal to 6 in this problem. So x is equal to 6. Okay. Now we have external, tangent, and secant segments. So this is just a diagram, okay? So if we have a circle like this, right? This is our tangent segments, okay? This is basically this diagram, basically in reverse, okay? So we'll try it on this circle as well. This is our tangent segment, right? This is our external segment, just half of this or whatever number this is. This is our external segment, the green part. And this is our secant segment. When people refer to this in word problems, you will have to know that. So let's try here, okay? I'm gonna try first. Okay, so this is our tangent segment. EA is our tangent segment. Our external segment is EC, and our secant segment is ED. Okay? Thank you for watching. Sorry, I've forgotten to add some things here. Thank you for watching. Please like and subscribe for more videos like this one. Make sure to watch the other parts of the series. That is very important if you want to learn all the things about circles, if you want to get ahead, or if you want to refresh, and if you want to just strengthen the topics. It is very fun videos. And they're also like 10 minutes long each, so it's like 30 minutes and you can literally learn so much about circles. And it's also by Think Sapling, so please like and subscribe for more videos like this one. Thank you.